Hi, students. Today we're going to talk about monetary policy and impulse response. We're talking about when the Federal Reserve does a monetary policy, the results are, there is immediate results and there is aftermath results. So we call it monetary forecast impulse response technique, impulse response technique. This technique is we learned when I was doing my PhD. Tom Sargent was a leader in this field and he got Nobel Prize. Tom Sargent, if you want to read about him, I made that available. He's American, got Nobel Prize 2011. This is another impulse response. He has a books, teaching, a lot of things. This is his email. If you can reach him, would be great. So Tom Sargent got Nobel Prize in 2011. The award cited their empirical research in cause and effect in the macroeconomy. Cause and effect. So when you make a monetary policy, it cause and there is effect that offset the first response, and so on and so forth. What's the goal of the Federal Reserve? Federal Reserve is to set inflation 2 to 3%. Sorry, 2 to 2.3%. From where this number come, nobody knows. But the closest you can get is natural growth of the population. That's what they're trying to do. But this number is not scientifically done. But that's Joe Paul, the current president, put this strategy. And the second goal for the Federal Reserve is a full employment, which means 3 to 4% unemployment rate. Percent. That's fine. So what does that mean? That means we're not going to have economy. Everybody is employed. Usually people are not happy with their job. They go into other job, they resign, or some people are learning new science and they're waiting a few months ago to the market. Like they're a nurse, they want to be a finance. Then it takes some time to transform from nursing to finance or vice versa. So these are the two goals. Inflation about 2 to 3%, 3 to 0.4% unemployment rate. So what's the empirical model that Sargent did? The goal of today's is impulse response technique. Impulse response technique. That you can use it in finance, we can use it in economics, we use it in physics and biology. When you get the vaccine, they do impulse response also. So I'm going to teach you the framework so you have an idea what does that mean. So if we said the inflation is a function of a constant, which is mean revision, plus a phi multiplied by MT. MT is a money supply. How much money supply? So if you put money, like suppose there is a supply of money is $60 trillion, then the inflation like this. Now, if you increase the money supply, you make it $65 trillion, then the inflation will go up. If phi is positive, then if you increase M, the inflation will go up. Okay, so on the other hand, if inflation going up, then the Federal Reserve want to target 2 to 2.3%. So to target this, they will reduce the money supply. When they reduce the money supply, then again, when the money supply going down, then the inflation going down again. So if you increase money supply, inflation up. If inflation up and gamma is negative, then money supply should go down. When money supply going down, inflation going down. When inflation going down, money supply will go up, and on and on and on and on. So there is a dynamic going on. So what's the notation? MT is a money supply at time t. Inflation T is inflation at time t. GDP at time t. Now, GDP at time t, I don't have equation here, but I have it here. The money supply influences GDP at time t. So the money supply is GDP at time t influenced by the money supply. When you print money and you give it more, which impact the unemployment and employment rate. Now, I don't want to add another equation for GDP, then become to be very complicated. It's a PhD level. I don't want to go to the complication. I just want to show you what is that impulse response. So when you graduate from our university, when your company asks you what's the policy, how this policy impact us, so you have to know that there is a first effect, the second effect, and the third effect. If you wanna do any policy in your company, there is gonna be multiple effects. So this is, we call it impulse response. The guy got Nobel Prize on it. So I'm gonna be very agnostic here. I'm not gonna talk about it. I'm just gonna put it here in the gray that there's another equation. I don't want to talk about it, but there's another equation. This epsilon t and another, that's an error term reflect an observable, like coronavirus, unobservable. Nobody expect that. Tomorrow, if we have a vaccine that heal everybody, then that's unobservable. Tomorrow, if we hear that Pfizer cause side effect and everybody should get a vaccine from the Pfizer, then that's unobservable. Nobody think this is coming. Now, phi, this and gamma are critical for us parameters to estimate. In theory, when you increase the money supply, inflation go up. So in theory, phi should be positive. Gamma is a parameter that means when inflation going up, the Federal Reserve in the next period lower it. So it should be negative. So how we do the empirical estimate, we need to estimate the parameters C, alpha, gamma, and phi. And this is structural model, means you have to estimate both equations simultaneously. At the same time or simultaneously. Simultaneously, something like that. So you say, Professor, well, okay, I can do OLS here. I can regress money supply over inflation. I have this, and then I regress inflation over money supply. You're not gonna get right results because you need to estimate this simultaneously. And there is a method called simulated method of moments. So when I was doing PhD, it took me a few months to learn this simulated method of moments and see how much complicated econometrics. But we didn't want to go there. This is not the scope of the class to beef up your econometrics knowledge. What we want to know that you cannot estimate each equation separately. You cannot estimate, you have to estimate it jointly because it's a dynamic. And that's the reason this guy got Nobel Prize, because he said you have to do it simultaneously. And he picked 5-6 moments to calculate, and he got that. If you want to get the data, here is the data. If you want to do it by yourself, if you know how to do SMM, here is the data about inflation, SPI, and GDP. You can get it from there. At least SPI, inflation, or money supply, M2. Inflation and money supply. Again, I'm going to do the empirical for you. So what is that impulse response? Suppose you estimate these two equations, you get the number C, phi, alpha, and gamma. Then what? Then if the Federal Reserve increase the money supply by 10%, well, what happened? If the money supply go up by 10%, then 10% multiplied by phi, it's going to increase inflation. So if phi is 1, for example, then 10%, then inflation will go up 10%. If phi, for example, 0.5 and the money supply increased by 10%, then inflation will go up by 5%. Okay, when inflation going up by 5%, then multiplied by gamma is going to change the money supply. Then the Federal Reserve see inflation going high, so they will lower the money supply by gamma. Then the inflation going up by phi 10, then if the money supply changed by gamma, phi times 10. So this change, if we call this change, for example, equal xx, so then the next one will be gamma multiplied by xx, which is gamma multiplied by this. This is the xx, and gamma multiplied by that. So when inflation going up, whatever going up because of phi, then again there is effect on the money supply. Is going to buy, that effect will be multiplied by gamma, will change your money MT plus 1. But when MT plus 1 going up, then inflation at time T plus 2 is going up. Then the inflation is changed by this, then the money supply changed by that. So it becomes to be a cycle here. So I use the parameters from Sargent, Tom Sargent. we find that we find it's near 0.06, and gamma is near negative 0.5. So if the Federal Reserve increase at time zero the money supply by 10%, then what happened? Okay, so what happened? This is what happened exactly in March 2020 when COVID hit. Unemployment rate was 33%. Inflation was negative. Deflation was. Again, the Federal Reserve doesn't want deflation. The Federal Reserve need inflation. Inflation is good for the economy. 2 to 2.3. The Federal Reserve want inflation to be between 2 and 2.3. A deflation, that means not good. So he has to increase the inflation. In Japan, for example, in the 90s, they say, oh, deflation is good. Real wages going up. And then as a result, the economy was stagnant in Japan in the 90s when the US economy was soaring. So deflation is not good. Deflation is not good. All right, so what the Federal Reserve did, he saw deflation, the Federal Reserve, and the unemployment was 33%. So what they do, it was also fiscal policy. The Congress and Donald Trump did the stimulus, and the Congress and Donald Trump talked with companies like Starbucks. I just met the CEO last week. So the government said, go open your Starbucks. Why are you closing? At least the drive-in. And Starbucks has a 5,000 drive-in. When they get the green light from the government that they can open, so they open the economy partially. And the Federal Reserve print money, increase the money supply. So how the Federal Reserve increase the money supply? The way it does, the Federal Reserve or Joe Paul go into the bond market. They start buying bonds. When you buy bonds, the seller, which is you and I or companies, they get the money. And that increases the money supply. So when they increase more money, they buy bonds. When the Federal Reserve buy bonds, like buy the notes, paper, and give money, then the money supply increase. When the Federal Reserve want to decrease the money, they start selling bonds. They selling bonds and get my money. Suppose I have $1 million bond, then the Federal Reserve say, I'm going to give you a lot of return if you give me the bond. So I say, okay, here's $1 million. Give me a bond, 6% yield on the bond. Yes, I'll buy it. Here's $1 million. Give me the bond. Then the Federal Reserve taking the money. That means money supply decreases. If the Federal Reserve wanna money supply to increase, then they start selling bonds. Money supply to increase, then they start buying bonds. They say, Joseph, you have a lot of bonds. I'll buy them. Whatever. Here's money. And then I take the money. I go for mortgage. I buy a house. I buy a car, loans, and things like that. Or I give loan to others. So through the bond market, increase the money supply by the Federal Reserve buying bonds, decrease the money supply by Federal Reserve selling the bonds and take the money from us. So what they did in March 2020, unemployment was 36%, inflation is deflation. They increase the money supply. Suppose 10%. When you increase the money supply by 10%, then this quantity going up by 10% multiplied by fee will be inflation impact on inflation. So 10% at time t increase the money supply. At t plus 1, here's the time, 0. And then you go to the next period. 0.6 is from 5. 5 equal 0.6. Multiply by 10%, then that means the inflation went at 6%, which is the current inflation, 5 to 6%. When the inflation going up to 6%, yesterday the Federal Reserve said, we're going to stop buying bonds. As a result, the money supply will go down 6.6 multiplied by gamma. Why gamma? Because inflation here increased by 6%. That's a shock. By gamma will be offset by, will be multiplied by gamma, will give you how much shock in the money supply. And the money supply will go down by 3%. Okay, when the money supply going down by 3%, so -3 multiplied by fee, then the inflation will go down. The inflation will be weak. By how much? Well, 3%, you go here, 0.6 times -0.3 will be, inflation will cool down, -1.8. When the inflation cool down, -1.8 multiplied by gamma, -0.5, then the money supply will increase 0.19. So the Federal Reserve will go again and buy a little bit of bonds. When the money supply increase, then the inflation will decrease by 0.54, which is a 0.9 multiplied by 0.6. When the inflation up money supply is down. When the money supply is down, inflation is down. When the inflation is down, money supply is up. When the money supply is up, inflation is up. When the inflation is up, money supply is down. So after 10 period, the sum, if you add 10% minus 3 plus this, minus that, plus this, minus that, the sum will be 8%. So the money supply basically overall increased by 8%. The impulse response factor is 8% divided by the 10%, the first shock. 1 minus that would be 20%. So if the Federal Reserve want to increase the money supply by 8%, they actually increase it at 10 and then let this system to go through it to go up down to 8. So that's what the Federal Reserve, that's what Tom Sargent said. If you want to get the 8%, start with 10, go down to 8. And then that means you're going to have inflation of 2%. So if the deflation was at 3% during COVID, then plus 5, negative 3 will be 2%, the goal of the Federal Reserve. And that's what happened in that period. Now I went to Excel and I put the 10% at time 0, and then we went negative 2, negative 3 at time 1, 2, and then we went up. So this is a change in money supply. I put a graph. So what's your homework? Your homework is not to create a video, just to fill in this table. I make it a few changes. I put phi at 0.65 and gamma at -0.55. I changed these numbers. And I said the shock is 15%. What I want you to calculate for me the impulse response factor and add a figure similar to this figure that we have here. So again, let me recap everything. Monetary forecast. Monetary forecast, it's not like one shock and you're done, like boom, neck out and you're down. No, it's a jabs. You have a policy, and as Sargent say, cause and effect in the macroeconomy. So cause, effect, this kind of stuff. The Federal Reserve goals are inflation 2 to 3, unemployment 3 to 4%. Empirical model, this is not the empirical model that Sargent has, because Sargent has also GDP and other things. But I simplify that just to explain the impulse response. Money supply, inflation. You cannot estimate this equation individually. This equation not related to this, because these are related, these error terms here. So you have to estimate them simultaneously. And then the empirical, you have to estimate these two parameters. You may be asking me, why we didn't use the C and alpha in our analysis? Well, for the shock, they're not going to make a difference, C and alpha. These are constant. So what you do is you're going to see something that is timely. T and inflation T are timely, subscript of T. So those are, doesn't matter what are these. It's going to tell you, these will determine the impact of the shock. So what's impulse response is the Federal Reserve in March 2020 make a shock, 10%, money supply is up, boom, inflation going up, money supply become cooled down, inflation cooling down, up, up, down, down, up, up, down, down. As a result, here, if you continue another 10 periods, it's going to be very minor. So you stop at 10. Maybe if you add, I mean, yeah, you see, look here, we're getting very small here. Next one will be less than 1%. So we're done. At the sum, we're done. And the impulse response factor is only 20% in this economy. 20% in this moment, in this parameters, 0.5 and negative 0.5 and 0.6. If you have different parameters, probably you get different results. And that's, you're going to see it in the homework. Your homework is to look this video, understand it, read about Sargent. It's a really good, good professor from NYU, deserve it. So, by the way, monetary policy, 3 people redefined the monetary policy. Robert Lucas, he got Nobel Prize in 1996 when he said the Keynesian is wrong, print money, make inflation, no real change in the long run. Neil Wallace has also, I think he's in Penn State now, I met him. And Tom Sargent from NYU, he talked about this effect and cause and effect. So your homework is to estimate the impulse response using different parameterization, and I make a shock 15% just to change an exercise. Once you get these numbers, go to Excel and create a figure like that. You see here 10% at time 0, T, delta, DMT here, and then I put the numbers, look here, 0, 2, 4, 6, 8, 10, and then we start with 10% shock, -3, and then plus. So that will show you the figure, how I did it. And then it's important to see the impulse response that you converge to zero. You become to be big, up, down, up, down, up, down, down, then you flat to zero. You're near zero now as after 10 period. And so do that. If you have a question, email me. Thank you very much. That's the impulse response. We're going to use it later, maybe in the semester, when we talk about exchange rate. Thank you.